Our integrated flex circuit assembly business is focused in 4 key areas: turnkey flex circuit assemblies, rigid flex circuit assemblies, PCBAs, and optical flex assemblies. Flex and rigid flex circuit assemblies are ideal for space-constrained electronic packages and enclosures, or for interconnect systems that are required to flex in 3 axes during normal use. Flex and rigid flex circuitry offers complete freedom to design boards and wiring for even the most densely packed electronic enclosures. In mission-critical applications, the ability to reduce or even eliminate discrete wiring in FR4 boards in favor of flex circuitry helps designers make the most efficient use of available space. Replacing complicated wire bundle assemblies with high-density flex circuitry ensures optimal size and weight reduction and virtually eliminates wiring errors, resulting in faster, error-free LRU installation and assembly. Flex circuits offer better resistance to high levels of vibration and shock and up to 1 million flex and duty cycles. Glenair turnkey solutions reduce customer expenditures on assembly and installation. The superior quality and reliability of flex assembly versus wire harnesses also improves total installed cost. Rugged, high-density, high-data rate optical flex circuits are also produced by Glenair for fiber optic backplanes and card-to-card applications. These assemblies utilize MT ferrule terminations as well as industry-standard terminations and support single-mode, multi-mode, and specialty fiber, as well as hybrid optical and electrical configurations. Glenair produces both flat and 3-dimensional designs with controlled routing length and bend radii. The principal design benefit of optical flex circuitry is the ability to implement fiber crossing or shuffle circuitry for the complex routing of fiber lines inside control computers and other types of LRUs. Standard optical flex circuitry parameters include optical fiber bonded to a flame-resistant capped-on substrate with high-density fiber-to-fiber spacing of 250 micrometers. Temperature range is -40 to 100 degrees Celsius, again with optimized fiber layouts, bend radii, and routing for high fiber count applications. Here's a simple cross-section of an optical flex plane layer with a single fiber crossing, calling out the thermally stable flame-resistant polyimide substrate, adhesive layers used to fix fibers in place, the 250 micrometer spacing of the optical fibers, and the very shallow bend radius design at crossovers to ensure long life and zero impact on optical performance. Glenair optical fiber circuit assemblies offer reduced installation time and reduced termination errors, reliable and repeatable performance, superior optical fiber management, complex crossover routing within minimal space, controlled low skew routing lengths, controlled bend radii, minimizing bend loss, and long length leads, eliminating the need for splicing within an equipment enclosure. The complete ecosystem of offerings built around Glenair's optical flex capability is extensive and includes Vita66 backplane connectors, MTP MPO connectors with prism lens expanded beam ferrules, and other components. Only Glenair offers such a complete range of fiber optic technologies for rugged applications, now including optical flex. Returning to our core capability in electrical flex assemblies, many of the assemblies we produce are extremely small, for applications where size and weight reduction is a requirement. Glenair is the world leader in small form factor aerospace-grade micro-D, nano, and micro-miniature circular connectors, and can incorporate all of these technologies into turnkey PCB flex assemblies. Utilizing ASC autoclave and reel-to-reel imaging equipment enables Glenair to construct extra-long flex circuits in one piece. Long assemblies of this type are employed as replacements for complex multi-branch EWIS wiring in commercial and military aircraft. Today we have COTS catalog solutions for various I/O connectors to AlphaLink board connectors, but Glenair's COTS capability is broader than this when it comes to standard point-to-point flex interconnects, and includes catalog flex assemblies incorporating micro-D to micro-D, nano to nano, and other PCB connector series. The fact that Glenair's catalog PCB connectors and flex circuit assemblies are available as standard COTS offerings has enabled the U.S. Department of Commerce to reclassify these products as EAR 99. Further, modifications to length, connector material, finish, mounting hardware, and so on may also be implemented in any catalog flex jumper assembly without requiring an export license. We are no longer limited to just straight geometry on the termination of flex to connector, and can now offer circuit assemblies with unique shapes like this angled connector termination. We can also supply the circuit assemblies with custom trace schematics. This is an important development as we are no longer limited to one-to-one wiring or uniform trace configurations, and can now offer traces handling power or matched impedance in an EAR 99 assembly. But again, exotic materials or constructions may still trigger a different classification. Here are the many printed circuit board connector types that may be incorporated into flex circuit assemblies, again without triggering more stringent ITAR restrictions. Glenair's unique value proposition starts with the wide range of printed circuit board connectors we manufacture in-house, our ability to fabricate flex circuit substrate media, execute all manner of testing and quality control, and deliver fully integrated flex assemblies from an operation situated and managed under one roof. Our basic design and fabrication capabilities remain essentially unchanged as we are still able to offer point-to-point or multi-branch connectorized jumpers, flexible repeatable routing for complex three-dimensional installations, the world's broadest range of high-performance I/O and board connectors, all with optimized reliability and high-speed, high-temp, high-shock and vibration performance. We tend to say flex circuit assemblies, but in fact our capabilities extend to rigid board assemblies as well. Our current operation is able to supply these more rugged and durable construction PCBs with hard mount points for connectors and surface mount components, as well as the ability to incorporate and mount components on both sides of the PCB. Rigid flex assemblies deliver the best of both worlds by combining durable, rigid board architecture with flex circuitry for double-sided component mounting and easy flex circuit routing. Rigid flex designs support 3D vibration-resistant flex routing plus hard mount points and stiffeners as required. The ability to integrate active componentry on rigid flex circuitry is an additional benefit of this hybrid construction. Here's a critical process that separates Glenair-designed flex circuit assemblies from commercial-grade non-ruggedized flex: the ability to ensure adequate strain relieving of flex media at the connector termination zone. In this technique, stiffeners can be used as tie-downs by extending them beyond the edge of the flex, or they can be added to areas of the assembly at critical points. The weakest point of the assembly is typically the solder joint, so it's important that these areas are reinforced, especially for high vibration applications. Implementing a well or dam into stiffeners prevents potting material from spreading into forbidden areas. Rapid prototyping is a key capability of our flex team. We can produce 3D printed assemblies integrated with flex substrate for mechanical fit check. Reviewing our most important in-house processes, we have upgraded all equipment sets to the highest standard to ensure all drilling, routing, lamination, and plasma processes are executed at the highest possible level. This approach extends to all photo processes from laser direct imaging, collimated UV exposure, and hot roll lamination, which have all seen new equipment purchases and upgrades. Glenair in-house wet processes for flex, rigid flex, and board fabrication include state-of-the-art media for the develop, etch, and strip process of printed circuit fabrication. In-process inspection of flex circuitry is performed on state-of-the-art optical and electrical inspection equipment. Automatic optical inspection, or AOI, verifies minimum trace width and spacing requirements, improving board repeatability and batch consistency. Flying probe electrical test equipment utilizes 4 independent probes for 100% continuity testing on all bare board circuits, with the ability to test over 3,000 circuits per minute. Glenair Flex assemblies are part of our industry-leading interconnect capabilities for space applications and include low outgassing Kapton substrates in both adhesive and adhesiveless varieties, and EEE INST002 connector and bare board screening. The Glenair PCB and ruggedized flex assembly footprint in Arcadia includes over 200 IPC 620, NASA J standard, and IPC 610 certified assemblers, testing stations with DWV, insulation resistance, and continuity testing, and overmolding capability with multiple materials, including high-sol for PCB terminations.